Definitely not the best graph. I don't know why the graphs come out like this, but do your best to couple what I'm about to say along with the solutions that you can find online. All right, but we'll talk all through them. I got a nice clean copy in front of me. So basically, looking at number 17, I like to attack this part first. Just try to get the 5 and know that that's a boundary. So from our origin, we go right 1, 2, 3, 4, 5. So there's going to be something happening along the line x equals 5. That's like our boundary. Something to the right of this is happening, something to the left of this is happening. So what's happening? Okay, so here we go. -6 is happening, constantly -6 if we have greater than or equal to 5. So we're going to go down 1, 2, 3, let's see, 1, 2, 3, 4, 5. It's probably about right here. But what are we going to have? We're going to have actually equivalent to -6 and to the right here forever. If we are at an x value greater than or equal to 5. So closed circle on that, -6 to the right. And then we got to do this, we got to graph this line if x is less than 5. So I'm going to go down 1, that's probably right about here on our graph. And then we go up 2 over 1. And then we're going to keep doing that. We can actually keep going up 2 over 1, up 2 over 1, up 2 over 1, up 2 till we get right here. And that's actually going to be an open circle. And then this is not the greatest graph ever, sorry guys. But it's going to look like that. Like you're going to have your slope of up 2 over 1, up 2 over 1, all the way up to the ordered pair 5, 9. That right there is the ordered pair 5, 9, but it's an open circle because we're closed down here. So basically, once you get that down, hopefully you understand that, the domain then will be all the x values that work. So that would be -infinity all the way to infinity, because everything here left to right will create an ordered pair everywhere. There is no break at 5 because we have an ordered pair right there. Then the range, we will be able to go down -infinity all the way up to, how high up will we go? Well, that's going to be up to that 9 with a parenthesis. Can't include that spot right there. It's all taken care of on the left part there. X-intercepts, absolutely. Again, hard to see here, but there is an x-intercept of 1/2, 0. If you're confused and you're like, well, I don't know where that really crosses, remember we did this one right here. So that was really the line y equals 2x minus 1. And if you have a strong understanding of x-intercept, that means you're putting in a 0 for y. So that means you have this going on. Add 1 to both sides. 1 equals 2x. That means this is going to actually cross. We know that the x-intercept is going to be 1/2. So 1/2, 0. And then the y-intercept there is pretty clear to see at 0, -1. Okay, and this one here, you want to look and you want to look at your values. So basically, what's going on? Well, state the domain range of each. Actually, we want to define this, and there's not a lot of room to do that, but we want to take and we want to define f of x here. I'll try to fit it right up in here. But basically what's happening here, and again, this is hard to see, but if you can look carefully at the graph you have, this has a slope of, what is that? That's down, what? Down 1, 2, 3 over 2, down 1, 2, 3 over 2. Very careful. Down 3 over 2, or if you go down 6 over 4, it's not -1. That is not the slope. It's down 3 over 2. So we actually are down 3 over 2 for our slope. So this is an mx plus b form. Well, we're going to add 3 because the y-intercept is 3 there. Well, when is this happening? This is only happening if we have x values that are greater than, okay, so -2 is less than or equal to x. X value is greater than or equal to -2, but also those x values have to be less than +2. Okay, so between -2 and 2, inclusive of -2. Okay, that is an or equal to there. All right, so that's what we got there. And then we got another thing happening. I'm going to do this part right now. Another thing happening if the x values are greater than 2. So if you look at that one very closely, you will see, my dog is barking, I'm sorry. Silas! Shh. And we're back. Okay, so we have a slope of rise over run, up 1 over 1, up 1 over 1, up 1 over 1, all right? So what's going on? We have a slope of 1, so that would be 1x, or literally just x there would be fine. But then we need to figure out where it's going to cross the y-axis. And if you follow that slope down, hard to tell on here, but it would be at -2. So 1x minus 2 would be the equation there for that part of the piecewise. All right, domain then would be -2. It definitely goes left and then all the way to +2, not including +2 this time, and then everything to the right of 2. Range, lowest it drops is 0. It goes all the way up to infinity. Again, the open circle there. X-intercept, there are no x-intercepts here because we have the open circle on the x-axis, and then the y-intercept would be 0 and 3. Okay, and then to finish off the piecewise functions, I'm not going to spend a lot of time on this bottom part here. Basically, just take the value and throw it in at the right spot. So 0 for an x value would definitely be in this middle region here. So when you plug in 0, you get 5 times 0 minus 1, or you just get a negative 1. When you plug in negative 5, where does that fit? That fits right here in the top one, so it's a constant function there, so that would be 4. Throw in the 5, that's going to be right here. And so when we have negative 2 times 5 squared, 25 times negative 2 is negative 50, and that's how we find those.